Hello, everyone. Welcome to this MongoDB live talk on beginner MongoDB mistakes to avoid. I'm Eric Reed, a senior consulting engineer with MongoDB, also known as the Mongo Silverback. A little bit more about that later. If you stick around long enough, you'll get the answer. So, welcome all beginners to MongoDB. Now, those of you out there maybe have never seen MongoDB before. Maybe you have a little bit of experience, maybe 5 years ago. Maybe you just have been thrown into the deep end of the pool here. But in any case, welcome to all of you. We've all been beginners at one time or another with MongoDB. I am no exception, as you will hear very soon. So, why is it important to embrace the beginner? Well, I think the most compelling reason I can think of is there are more MongoDB beginners than ever, by far. Any usage curve, download curve that you might see with MongoDB shows us that it's more popular than ever, and more people are either checking it out or committing to it, in which case you have to start somewhere. Sometimes it seems like a relatively different or new technology like MongoDB seems very hard to learn because many concepts are new. This is not the case. And hopefully, as a result of this talk today, you'll get a better sense of that and a little bit more confidence in what you're doing going forward. So, first of all, when they give us the MongoDB live presentation slide templates, they say, yeah, you can take one of these icons that we've developed for you and use it. And I immediately saw this icon that represented navigating through a maze. For those of us starting with MongoDB, it often feels that there is a giant hedgerow maze out there that we need to get through, especially if our bosses have said, yeah, you need to get through this maze by Monday. So I found it a very apropos icon to set framework for this talk. With being a beginner, we want to remove as many barriers as possible to adoption of the technology, of the concepts, of the features, of the products. We're MongoDB and we sell a lot of this stuff, but also there is a giant, thriving MongoDB community out there, of which we're a part, of which you are now a part. We want to remove barriers to adoption. The fewer perceived barriers there are, the better. And again, I too was once a beginner. In fact, I came to MongoDB 2.5 years ago from Oracle. And at that particular point, I had never touched MongoDB before. They said, we can teach you this stuff. And they absolutely did. But the mountain that MongoDB appeared to be before me at that time seemed huge. MongoDB, quick growing community, quick growing company, lots of buzz, lots of substance to it as well. Really seemed like, could this possibly be insurmountable, especially for those of us who've been in the industry a while? Well, the answer is yes. And since starting at MongoDB, I have realized that there is a huge need for this type of outreach, this type of confidence building that can get you, like me, from the beginning to where you need to go with MongoDB. Let's talk about being beginners in MongoDB. Most people who come to a non-relational database system have some experience in RDBMSs and the inherent concepts. For a lot of us who've been in the industry for, dare I say, decades, this is very significant experience that is very burned in to our collective consciousness, to the way in which we do work with data. And sometimes it takes a little bit of time to, if not unlearn that, put that to the side. Now, most beginners are new to MongoDB, that's for sure. They may have tried some other graph database, NoSQL database, something else that isn't relational. So that's good. That breaks you out of the shackles of relational thinking. But again, you have to approach and absorb MongoDB on its own merits here. I alluded to this a minute ago. Some people are curious about MongoDB and are checking things out. They downloaded the community version. They want to take it for a spin. Maybe they have a pet project on the side they want to do. But many people, as part of their jobs, are told, we have an effort to move some applications to MongoDB. Your application will be that. Go. And so they are faced with what they see as porting or modernizing an existing relational-based application into the MongoDB space. And in those cases, we put up a little bit of a red flag saying, okay, we know it's common, but if it's going to happen, keep an eye that you need to check your RDBMS expectations, practices, predilections at the door. For those of you who have lasted this long in this talk, I'll now answer the question that was posed at the beginning, which is, what's a silverback? Well, I've been in the industry for a little while, actually almost 40 years. Don't hold that against me. And when I left Oracle for my next endeavor, I was considered what's called a silverback. And that comes from the term of older gorillas in the wild who have a silver streak on their back. That term is also used in the tech industry. And as such, I've realized that not only for beginners who are younger, but especially for beginners to this technology that have several decades in the industry, there really is a place for how to come up to speed and how to get comfortable with technology like this, pretty much any other relatively newest technology. So that's where the term silverback was born. It's something I've gone with a little bit over the last couple of years. You'll see at the end of the slides, there's a website that I maintain, which hopefully is of use to those who are starting out in Mongo, those who are not completely comfortable in it, and especially for those of us who consider ourselves silverbacks. All right, so a little bit of context here. I'm a consulting engineer at MongoDB, and consulting engineers go out and work with our customers of the MongoDB Enterprise or any of the other products that we produce and help them apply best practices and help solve their problems, basically. When you've done this for several years, you get to the point where you realize that we've pretty much heard every possible combination of where customers have come from and what their expectations are, etc. So we've heard it all. We've also solved it all. We've cracked some pretty hard problems for customers. But what I've realized here is that to me, and what I have seen in the last 2.5 years with new customers, is that the most crucial phase is not solving the hard parts of things. No, the most crucial phase is getting started. Okay, this analogy only goes so far, but if you think of it, if you stumble out of the blocks, if you fall, if you lose your footing, if a seagull flies into your face, not only will you not get as fast a start as you had hoped or your boss had hoped, but you will get discouraged. You will think, this is hard. you will think, this technology isn't quite what I was thinking it was. I don't know if I want to use this here. Well, fine. If we can smooth this out a little bit, to some extent, fewer people fall, fewer people slip, etc., the overall experience for new MongoDB users, for beginners, will be better. My ulterior motive in this, and what I do even when I am teaching customer courses face-to-face for beginners, is to save some of the pain, to be able to make it a little smoother, to be able to get customers, users, to be able to say, I accomplished something. I think I'm going to be able to do this. That's really what I'm looking to do, both in my training courses and here. So with that, the title of this talk is MongoDB Mistakes to Avoid. So let's speak of avoidance just a little bit. What I hope to impart to you are some basic concepts, as well as some more specific things that you can hopefully keep in the back of your mind and avoid going forward as you start your journey with MongoDB. All the pain that I have seen with beginners, hopefully I can help prevent in your cases here. You will run into things. We all run into things when this happens. When you learn something, it isn't necessarily a smooth ride unless someone is leading you by the hand every second of this. That's how you grow. That's how you learn. So the first category of things to avoid, let's say, really gets back to the notion of most of us came from relational database land. And as such, we've got a lot of things that we arrive with here. And some of those are not good things to keep with us as we're learning this. The recommendation is set this stuff down. Put it to the side for now. It'll help when you learn MongoDB. Doesn't mean you have to forget them. You'll probably still be working with relational databases. But because they are fundamentally different animals, it's really worth keeping in mind several things. The first is the RDBMS theory, the theory of normal forms, third normal form or fourth or fifth normal form as a goal when you are designing your database schema is something that here isn't applicable. As you know, or as you will see a little bit, in many ways, the opposite is true. We don't want to normalize automatically. We actually want to trend toward denormalizing. So when you walk in and say, oh, I'm going to have products, I'm going to have people, I'm going to have transactions, I'll put those all in separate collections. Collection is analogous to table for those of you who don't know. And then I can just join any possible query, join across those particular collections or tables to get what I want. That doesn't work here. So that's one. Other mechanisms, such as it's a different query language. The syntax is different. The semantics are a little bit different. So you need to keep that in mind. So with that, the biggest thing I ever see with beginners in MongoDB is they don't put this stuff off to the side. Or maybe they're told, I want you to do the minimal amount of work to get this application from an RDBMS to MongoDB. All right, we've heard that sort of thing many times, but I'm telling you in this case, that will only lead you to trouble. Another topic when it comes to the design of the schemas in MongoDB is right along these lines, which is don't think you can come along and say, I have these tables in my relational world, and I will just make the collections in the MongoDB world the very same things, right? Makes sense to me. Won't work. And it won't work primarily because the best relational schema that you may have come up with for the original application, probably third normal form, or maybe some variation on that, is not going to work very well in Mongo. One has to go back a little bit to the drawing board and say, what's the problem I'm trying to solve? And what's the best schema in the MongoDB world that's going to be able to help us carry that out? The next point around schema design, it really comes down to the fact that in the relational world, we could normalize our tables, and we would then know that we could join across any combination of those tables. We actually didn't need to know what the queries were that were going to be used against it. It worked really well. It worked really well because that design was predicated on a computing landscape from the mid-1970s. And that has worked very well in the decades since then. MongoDB is not predicated upon that computing landscape. Its landscape is much more recent. So while with relational database design, we can get away with that type of thing, in MongoDB, we need to know what the most important queries are going to be before we can design a schema which is going to meet our needs properly. This is a really hard thing for people to get used to. Lastly, as you can probably tell from what I've said already, avoiding joins whenever possible is really something you want to do. Joins are expensive. They take a lot of computing power in MongoDB, and they affect performance. So whereas in the relational world, we could say, normalize and join, we don't need to know our queries in advance. Here, we need to know our queries in advance, and we need to craft our collections, the document structure in those collections, in such a way that we want to avoid joins. Sometimes it is not possible, but you do not want to assume it, you don't want to lean on it, and you want to minimize that sort of thing as much as possible. Can you tell from the text I put there with joins? All right. Another topic, getting started, whether or not you come from a relational background or not. Number one, avoid unnecessary complexity. Start as simply as you can. Master the basics of MongoDB, the document model, the query language, replication perhaps. Basic things here. There is a lot of good functional All right. So whether or not you come from a relational background or not, getting started in MongoDB, several things that you can and should avoid. And the first one has to do with don't try to do everything at once. Don't try to learn every feature. Don't try to jump right into, let's say, the aggregation pipeline. Start simply. This really helps keep the frustration down because you're not trying to ingest all these concepts at once at all these different levels. Don't worry about what Atlas is. By the way, it's our database as a service, but it's built around the MongoDB basic concepts, which you need to learn first. So pick several things, the basics, take one of our online courses, which I'll talk about later. Master the basics first. Avoid trying to play with MongoDB with a mechanism that's overly complex or overly bloated. Don't figure that you have to get a sharded cluster deployed right off the bat. You can install MongoDB Community, freely available, freely downloadable, into your laptop to get going with a single process. You could use our Atlas free tier if it looks like you're going to be using our database as a service without spending any money up in the cloud. Start simply, don't bloat. avoid overconfidence with the tool set. And this was something I had to do to make it work with the word avoid. But the basic message here is people can get really frustrated at first when they're typing command line things such as please start the Mongo shell or something else, and they're not really familiar with what all the binary names are here. Example, Mongo S is a binary, but it's not the Mongo shell. It's actually the Mongo sharding front end. So taking time to say, okay, I know that I'm on a Linux command line. Here's how I run the shell. Here's how I determine that I'm in that Mongo shell. Here's how I exit it. So I'm not typing Linux commands in the Mongo shell. So I'm not typing the reverse. And then, and this is a pet peeve of mine and something that will tick off some of my new trainees when I am giving courses, avoid saying, well, what's the MongoDB equivalent for this function in Microsoft SQL or Oracle? What I always respond to with that, and this is where I draw the ire of some students, is I say, no, don't worry about that. What problem are we trying to solve? Don't try to do the minimum of saying this feature must be over here and we must have this feature in MongoDB. No. Ask what problem you're trying to solve, back off, and then determine what the right set of features or functions in MongoDB will be to do that. So again, what problem are we trying to solve? All right, so now some things to avoid for the developers in the audience, and then we'll transition over toward the ops side. Several things, including avoid getting hung up on the need for a fixed schema. If you don't know already, unlike most RDBMSs, which force you to define a two-dimensional tabular definition of what fields do all the records in that table have and what types are each field, MongoDB does not have that. We are much more freeform. There is the ability to lock things down, but we don't recommend it in most cases. So the notion that a collection can contain documents with different shapes, i.e. different fields, and or the same field with different types of values in there. Field A in one document could be a string, and in the very next document, field A could be a number. That's totally fine. It's encouraged because the flexibility is very important, but it's very new to a lot of people. So don't get too hung up on that sort of thing. Along those lines, assuming you have a collection that would have some documents that might not have any value for a particular field. Again, let's say field A. And in the first document, A has a value. In the second, traditionally, that would be what's considered a null value. And that field would still be there in that record, even though there was a null value to it. Well, in MongoDB, the field simply wouldn't be there. There would be no field A. Yes, there are cases where we can specify that field A has to exist. There are always cases like that. But generally, you can simply say, rather than taking up disk space with a null, which I see at a lot of customers, they still have a value of null, even in a MongoDB document. You don't need that. Save the space, use $exists, which says, hey, if field A exists, then do something with that. That is another way that we help sort of break the traditional RDBMS assumptions and allow us to sort of think more freely to be able to solve the problems in front of us. Avoid very large documents. Most people know that the maximum size of documents in MongoDB is 16 megabytes. That isn't going to change anytime soon. It's been that way forever. We have plenty of mechanisms that allow you, the customer, to be able to still put in very, very, very large binary objects into your database. It's called GridFS. I'm not going to talk about it today, but you can look it up. So it doesn't limit the size of the data necessarily that you would have, except within that document. 16 megabytes is the limit. You should not have any scenario, and granted, and especially with arrays, which is a data type that I'll talk about in a minute, especially with that, we can have varied sizes of documents within the same collection. But you want to make sure that there is no case where you might get near that 16 megabyte limit here. Avoid too many indexes. Indexes, like with any other RDBMS, exist to make queries faster, certain queries faster. And that's a really good thing. In MongoDB, indexes also, by definition, and this is true of other DBMSs as well, will make the subsequent writes a little bit slower because we are updating the actual index data structure every time a new write is done. Over time, and with more and more indexes, we have found that you can have too many, even though there is a physical limit of 64 indexes per collection. We have found that around 15 to 20 is the point where the write slowdown starts to get out of balance and means that even though the queries are going much better, overall the application slows down. There are many strategies which are included in our courses and our documentation that can point you for ways that you can minimize the number of indexes that do the most good for your queries in many different ways. But keep that in the back of your mind as you're starting. And then something I get so much in our introductory courses, we have something called a text index. In reality, rather than being something like an entire Elasticsearch set of functionality, text indexes really are simply taking text fields or string fields and chopping them up, they're tokenizing them, and then allowing certain rules to be applied to those, such as prefixing and suffixing and language-specific rules to be able to say, I can do some very basic searches against that particular field within a collection. But it's not elastic by any stretch of the imagination. Too many people assume, and I had one customer who once said, we just want to implement Google search within our enterprise. Now, if I was presenting this live, several of you probably would be giggling softly, because anytime that someone says, I want to implement Google search internally, they don't really know what their requirements for search are, because that's way too broad. If you want to do something with the functionality that something like Elasticsearch would give you, you're probably going to need to bolt Elasticsearch onto the side of your architecture, or make use of our database as a service Atlas, which has an option to be able to do such searching. When you encounter text index, though, basic MongoDB text indexes don't over ascribe too much potential benefit to those or too much functionality to those. They're fairly limited in what they do. Other dev things, and now we're getting a little more detailed, and those who are brand new and have never even seen or touched the query language, this might not make as much sense to. Booleans, for example, in MongoDB behave a little bit differently, only because of what I just mentioned, which is a field might not exist. So therefore, a particular field might have a true value, a false value, or unless you really lock it down, it might not even be there. And so the semantics of the logic behind that change a little bit. And to wit, we would say, If I have an equal true for some field, that is not fully equivalent to not equal to false, because we still have the case of what if the field isn't there. So this also helps expand beginners' minds. Don't make use of some of the more powerful but non-basic features of MongoDB necessarily when you're first starting out. And a good example of that is the aggregation pipeline. For those who don't know, the aggregation pipeline can be considered querying on steroids, with incredible power and flexibility to do some very, very interesting and impressive data manipulation beyond the normal sort of find, insert, replace, delete, update functionality that you would have. What I tend to recommend is that, yes, the aggregation pipeline is out there. It does some amazing things, but you don't necessarily have to learn that right off the bat. If and when you need the functionality that aggregation pipeline will give you that you can't do any other way, yes, that's when you jump in. You absolutely should know about it, but don't do it until you absolutely need it. It'll save you some grief. By the same token, ACID compliant transactions, which are now fully in MongoDB, originally were not, are something that many customers will say, yeah, we're going to have transactions. Well, what exactly is a transaction? Multi-document ACID compliant transaction simply says that we can wrap some number of operations, write operations, in one of these transactions. It then guarantees that either none of those things get committed or all of those things get committed. That's essentially what a transaction is. And so many people say, yeah, okay, I've got a document I have to update in collection A and then another in collection B, and I either want all or none. Well, there's another option there, that in a properly designed MongoDB schema, you would take the information that nominally would have been in collections A and B and put them into the same collection, embed the information from one in the other. And in most cases, that's totally doable, and it obviates the need for any sort of ACID transactions. So we put ACID transactions in, and it was hundreds of person years of work to do. It's done very well. It's done very completely. But most applications, and I would say 99.5% plus of applications in MongoDB, will never need to make use of ACID transactions if the schema is designed correctly. A few other developer-centric things to avoid. Arrays. Arrays are a data structure in MongoDB documents which are incredibly powerful, which don't necessarily have an analog in other types of DBMSs. Looks, smells, acts like an array as you're used to from data structures class. They can have incredible advantage for doing certain types of things, but an array can have some number of elements to it. And if that number is potentially unbounded, whereas this array is 10 elements most of the time, plus or minus, but once in a while it's 10,000. That's an extreme case. But still, you run the risk of quite possibly exceeding the 16 megabyte limit for documents. That's the most hard and fast one. That will throw an error if it happens. But then there are also things that you have to worry about. The size was the first one. But if you have an index on an array, it's called a multi-key index. The size of that index in RAM is going to be large. And if you have an array that sometimes can punch much larger, like 10,000, you are going to have some very, very large indexes, which, as we'll talk about in a minute, is something you have to keep in mind because it takes up RAM. And then I mentioned the 16 megabyte document limit. So having cases where an array generally is of a manageable size, but might sometimes in an outlier case be much, much, much larger, need to keep that in mind and avoid that if at all possible. Avoid your initial instincts to normalize your data design. You basically, in MongoDB, want to denormalize as much as possible. And I'm not saying, oh, you should be able to have one collection that rules them all. No, but you don't want to say, I'm going to normalize and have 50 collections and join across them. The less you normalize, the fewer joins you will have to do. But more importantly, the more than any given document, when retrieved from disk, is going to have most of the information, if not all the information you need for that particular query, and it happened in one seek. Yes, if you've indexed it correctly, it'll be less that has to come from disk, but the bottom line is still the same. Proper data design, schema design, is going to really help in MongoDB. And so fight those instincts to normalize. Another one is avoid too many namespaces. And a namespace is simply the cross product of the database you're in and the collection name. This is really saying avoid too many collections. From a pure mechanical standpoint, below the covers of MongoDB, deep in our storage engine called WiredTiger, there's a lot going on there, and WiredTiger does it very well. But what we have found is that having tens of thousands or hundreds of thousands of collections in a particular database, in a particular instance, leads to many, many issues, primarily around replication, around backup and restore. It just takes a whole lot more time to do what you would think would be, oh, it's only a few hundred gigabytes. This shouldn't take too long. Yes, I have 10,000 collections. However, that has bitten a number of our customers many, many times. Temporary collections. Yes, those are fine. Temporary tables, those are fine. Clean them up if they're really, really temporary. Don't leave them sitting around. I've had many customers that don't properly clean up and they get into this issue. A last one, be careful when using object document mappers, right? There's some very good ones out there. Many, many, many customers use these. Mongoose, Morphia, Hibernate OGM, Spring Data, all very valuable in terms of being able to abstract your data model and allow the application to work with abstractions a little bit different from native Mongo. Why I say be careful is primarily, number one, these ODMs are not explicitly supported by MongoDB. So if you're an enterprise or an Atlas customer with a support contract, we will not necessarily be able to fully support them. We oftentimes will make a best effort in doing such things, but we've had many cases where at the end of the day, it was an issue with that ODM and we weren't able to provide satisfaction. Okay, those were some dev-specific things to avoid, and now we're going to sort of transition toward the land of operations, but there are a few things that we can talk about which fall kind of under the category of dev/ops. Not traditional DevOps like you probably know it, but things that kind of straddle the line. And they straddle the line because MongoDB, with its flexibility and the amount of functionality it has a lot of things that are not just going to be decided upon or acted upon by only developer teams or only by operational teams, by DBAs and such. An example of that is avoid defining indexes without knowing the query patterns. Now, if you have been following some of the basic rules that I had been talking about earlier, which was you really can't define your schema at all without knowing your query patterns, then you'll probably never get to this and you won't get tripped up on this. But there are many, many users, many customers of MongoDB that I have seen personally that will define a set of indexes. And those indexes are simply done because, yeah, probably people are going to want to be querying those particular fields or those sets of fields. Nobody has come to the people who define these indexes with the list of requirements saying these queries are what we're going to do. This is an example of you must have a priori knowledge of how your data is going to be used. And specifically here, queries, you need to know what your most important queries are because that's where you will define your indexes for. You very well may not be able to define every index for every query shape you've got. There can be lots of queries. You only have 64 physically, 15 to 20 in practice indexes that you can have for a collection. And it means that you need to prioritize your queries to say, this one's super important, so we need an index for it. And do that for the first 15 or 20 of these. Similarly, when it comes to sharding and shard keys, and sharding, for those who don't know, is an advanced concept that gives us infinite or seemingly infinite horizontal scalability for our data sizes and our workload sizes by adding more hardware to it. That's essentially what I'll say for this here. They are controlled through the definition of something called a shard key, which then says how the data will go out to these multiple copies of the hardware that are allowing us to scale to petabytes. We scale actually tens or hundreds of petabytes now, I think, are our biggest ones. But these shard keys are something that oftentimes developer teams will say, "Yeah, we don't need to worry about that because we don't care how the data is distributed across, these different sets of hardware. And we'll leave it for the ops team to do." And that's a no-no. The shard keys, much like indexes, can only be properly defined by knowing what a priori your query patterns are. So these are somewhat analogous, but both of them point out the fact that these are decisions that have to be made together, dev and ops. They can't be done in a vacuum by one side or the other. Otherwise, there will be problems. The last one, on this page at least, that we have is avoid determining your working set. Yes, I'll define this. Avoid determining your working set too late in the process. Again, you have to know query patterns, but first, let me digress and define. A working set is a fairly common MongoDB concept, which is essentially how much memory do I need to be able to run my system in a steady state at peak. This tends to be determined by the types of queries that are going to be running at this steady state peak time, and is very key to determine how much in the way of resources do I need? What size boxes, what size Atlas instance? And so again, this is something that we have to know. The query patterns in advance and dev and ops have to be a part of determining together. Let's go a little farther with this working set thing because it's very, very key when you are setting up MongoDB instances from scratch. And the ops side has to figure out what size of equipment, and the dev side is not as worried about that, but they know hopefully what their query patterns and their data design are going to be. So the definition of a working set in MongoDB is the amount of RAM required to hold such things as the actual data from the collections themselves, indexes, and some other things, the amount of memory necessary to do that at peak workload, steady state peak workload. The way in which it's defined And I just couldn't resist using some of the nice mathematical characters, but I'll explain exactly what this is. It's the summation across all the collections in the database of the percentage of data for each of these collections that needs or should be ideally in memory at this peak steady state to be able to run as efficiently as possible. We can't have everything in memory. Well, you can. You can make use of MongoDB's in-memory storage layer, storage engine, but rarely these days do we have databases that fit nicely into the memory of commodity boxes. And therefore, we're always having to worry about what's most important to us. That should be in memory, ideally, so that we're running at memory speeds rather than at disk speeds. And there are a lot of nuances in shading. There are entire presentations, courses having to do with our Wired Tiger storage engine and the way that it manages memory, the caches that it has. But when it comes to defining the working set, it's seemingly straightforward here. What percentage go across each collection at peak steady state? I'm going to have these queries that are going to be running against these collections. And in general, on average, on balance, we're trying to approximate here how much of each collection probably should be in memory. Sum that up. That's part of what we're shooting for here. But then we add into that the size of our indexes. All indexes should be in memory. They don't get pinned in memory. We as the system or you as a user are not able to pin those into memory. So again, with this approximation, we are saying leave enough space that all the indexes can be in there and they are not getting paged out and paged back in all the time. There are plenty of examples that I have personally seen where this can be an issue. I had one customer that was wondering why their application was so slow. They had 32 gigabyte memory systems that thought were quite beefy. But it turned out when we added up the size of all their indexes, that was 31 gigabytes. And that was kind of at the root of their problem because that leaves very little room for the rest of everything else. Last thing to consider is not something summed up across all the collections, but rather the number of server connections. Again, this is memory on the MongoDB server. There's a client-server model. You'll have lots of clients talking simultaneously to your MongoDB server. That's perfectly fine, but each one of those connections requires 1 megabyte of server RAM. I once had a customer who estimated they could have 10 to 15,000 simultaneous connections. It's a very large system. That's perfectly reasonable, but that's 10 to 15 gigabytes then that will be taken away by the system for connections. The difference in this third one from the first two is we're doing approximations on the first two to make sure we have roughly the right amount of memory, although it can't necessarily get pinned into memory. Here, this is memory that you don't have any option on. It gets taken away from the overall server memory pool here. And that can eat into this. So with all of this, we are trying to say that more or less we will have enough memory for this peak steady state. Will there still be paging going on? Absolutely. We want to minimize that as much as possible. All right, let's move on to the operations side of things here for a few things to avoid. The first one is a particular thing called bind IP, which is a parameter to the basic MongoDB server, the MongoD process here. It is something which tells the server where to listen for client connections. In the old days, this happened to come with MongoDB out of the box with a value that allowed anybody, anywhere, with a network connection to talk to it. Since that time, we've realized that has been not the most secure out-of-the-box configuration, and as such, we changed the default value to only listen to localhost. The key when it comes to bind IP, and the key for me when I started with MongoDB, I actually misunderstood, even though the documentation is pretty darn clear, what this means. Bind IP is not a whitelist of addresses to listen to. It is simply a network interface, be it a physical NIC or a virtual NIC, to listen to. In the case where most systems have just one of these, you're simply either saying, I only want to listen to localhost, which is pretty rare in a production environment, or yes, I'll listen to everybody else out there. Great. Many institutions will have multiple virtual network interfaces on their servers so that they can have isolation of traffic. You can have pure application traffic on one subnet. You can have non-critical, non-application traffic on another. This allows us to be able to say, I only want to get connections from that subnet where my application servers will live. That's essentially what it is. So don't mistake it for being a whitelist. Another thing to avoid, and this gets to one of the basic tent poles of MongoDB functionality for high availability, the replication that we offer. Replica sets are the physical instantiation where we have multiple servers which give us high availability and the ability to fail over without the application really noticing anything there. By default, when you have a replica set, all reads and writes will go to just one of those nodes at any given time. That's called the primary. And therefore, whatever read and write total workload you have needs to be something that you need a server of a certain size to be able to handle that. There are situations where you can do a little bit more workload scaling by sending some of the reads to one of those other nodes that heretofore simply existed for replication for high availability. Those are called secondaries. The main one is called a primary. You can send some of the workloads to these secondaries if you know what you're doing, and that's why I talk about being reckless. And the best way to envision this is to consider what happens if I have my quote unquote normal workload, all my writes and most of my reads going to whatever the primary node is at any given time, and my reporting or some other application is reading from one of these other secondaries so as not to overtax that first node. What happens if the first node, the primary, fails, and this secondary node, which is getting these extra reads, suddenly inherits all the workload, all the writes, and most of the other reads from that failed node? We then have a case where we might have that node with too much work for it to handle. And so we tell people, if you're going to read from secondaries, be able to have this failover case. Otherwise, you will get an unpleasant surprise. There is a corollary to this, which is don't use replication for scaling. That's what sharding is for. Replication is for high availability. And the previous example showed why that could be a problem. The last one on this page might seem quite intuitive, but when I worked with a customer, this was a genomics customer several years ago, and they had very interesting, very useful data in their production instance, which they had not backed up in 3 years. Normally, if you're not a system of record, that might be okay. It might be available somewhere else. But in this case, that was the only copy anywhere of this. Now, what had happened was the initial deployment was done by one group, and then later on, after that first group had been let go, or they brought in consultants, I don't remember, it was taken over, but nobody had noticed that there was no backup going on for this production instance. They were skating on incredibly thin ice. And while you wouldn't think this would be something that would be in a talk like this, I've seen it twice. So never assume, always ask the questions, and in this case, always back up your production data, especially if it's not a system of record. I mentioned sharding before, which may be a new concept to some of you. Again, it allows for horizontal scaling by adding more equipment, more machines, more computing power to the mix here. It is a concept which is relatively straightforward in principle, but requires lots more equipment. It requires a lot more pieces, a lot more moving pieces. It is absolutely the way to achieve horizontal scaling if your existing hardware isn't sufficient, if you're about to outgrow it. But we have seen customers that will say, oh, we're probably going to use sharding, and so we'll just put everything into place. Our virtual machines are fairly cheap to get, but they're not quite serious about it. And therefore, the recommendations we make are sharding is something you want to keep in mind if in the future you're going to need the horizontal scaling, but you don't have to necessarily implement it right out of the gate. And if you're not really sure that you may ever have to use it, don't start with it. There's a lot more complexity. There's a lot more computing infrastructure that, especially if it's on-prem, you are going to have to provision, maintain, etc. So don't shard until you really need it and that you're serious about it. Some customers will provision the hardware for it and then implement it in a halfway fashion, and they have all of the downside without any of the upside. Another thing related to sharding is predicated on the fact that the way in which we horizontally scale by adding more hardware is we start with this basic thing I mentioned before, the replica set, which gives us high availability at relatively small scale. And then you duplicate those replica sets, at least in configuration. You basically are doing this sharding based on replica sets. You don't have to. There are ways that you can do it in a much cheaper fashion, but then you don't get the high availability. And in today's production environments and large systems, that's almost a non-starter. You've got to have both the high availability and or disaster recovery that replication gives you before you even get started with sharding. But I have seen customers that try to do it on the cheap and they get bitten. The last one here in the ops section has to do with a type of node in replication called the arbiter. The arbiter is a node that will take part in the replication, but it doesn't hold any of the data. It can do things like voting for who the next primary might be, etc. But it's a very lightweight type of node that many customers like to use, in part because you don't have to pay a licensing fee for that particular node, and that's very attractive. There are many known problems with misuse or incomplete use of arbiters in replication that cause us to say we really would need to see the justification for use of arbiter, because otherwise it's not worth whatever perceived savings you have here. Okay, that was a lot of avoids, wasn't it? It's kind of a downer. Nope, it's not a downer if it's going to make a big difference to you as a beginner getting started. So we can go into things that are a little happier here, and that starts with the resources. The resources available to the MongoDB beginner today are better than they've ever been for several reasons. And one of those is something that was announced and deployed in recent months, the MongoDB developer community forums. Heretofore, we had Slack channels that we ran for developers in the community. We would monitor things such as Stack Overflow, Google Groups, etc. I think we still do that to a certain extent as a company, as the center of the MongoDB community. But the developer relations group this year launched the community forums. There's a URL for it. There are lots of beginners there, and there are lots of us who like to help beginners there. It's completely free. It's very professional. Many, many, many MongoDB employees and experts in the industry lurk and actively post in the community forums. I strongly recommend you sign up for that right off the bat. The MongoDB blogs have become a very good source for best practices and success stories and other types of things, usually written by those of us at MongoDB. Sometimes we have guest authors here. But I especially point this out because in the last year or so, in addition to lots of best practices, there have been a series of blog posts done on patterns, data design, schema design patterns, which are extremely helpful to data designers to say, well, in MongoDB, if I have applications that act like this, or I have incoming data that acts like this, what if I have an Internet of Things application with a data stream which has lots of things coming in, and we may have to do things in time series, et cetera, et cetera. There are somewhere between, I think, 10 and 12 of these patterns that have been observed and formalized and now written about in this blog series. And I strongly recommend that as well. The last one is MongoDB University, which has been around for quite a while, which has courses developed by MongoDB, presented by professional trainers at MongoDB, but that for the longest time were only available to those who paid MongoDB for support, enterprise customers and such. This year, MongoDB became free to everybody. They are very good courses, and I third strong recommendation in a row on this page, sign up for MongoDB University, start with the basic courses. You'll thank me later. All right, there are some publicly available tools that are free to any MongoDB user, community, enterprise, Atlas, whatever. First one of these is called Keyhole. This has been developed in the last year by a peer of mine and is used to measure performance of an existing MongoDB instance by collecting stats. It also can be used to generate workload against a MongoDB instance for the purpose of performance measuring or statistics collection. It's relatively easy to use. It's written in the Go programming language. And I would say this is something you should have in your arsenal when it gets to the point that you're dealing with things such as performance and scaling, etc. Second tool I recommend is actually a suite of tools called NTools, which has been around for several years, again, developed by a MongoDB employee. And MTools, written in Python, is a collection of scripts and tools that allow us to look at MongoDB log files, which are fairly easy to find for any given MongoDB instance. They help us parse them out to find certain events. They allow us to filter. They allow us to visualize or get textual representation of such things as slow queries or other types of operations, and then view those. It also includes a tool called mlaunch, which is very handy to set up very complex test environments. For example, I can, from my laptop, when I am at a customer, spin up a replica set or a sharded cluster of a particular MongoDB version running right on my laptop and be able to debug an issue, reproduce an issue, whatever you want to do. So mtools is the second very useful one to have in your backpack as you go along here. Third one, written by one of our consulting distinguished engineers, John Page, is called POC Driver. And this is a Java-based tool with the source that allows you to generate a customized workload to work your system out, and to then be able to observe how it performs, how it scales, etc. It is useful not only just as the tool to be able to say, please generate this workload and run it over this amount of time and ramp up in this way and ramp down in this way. And here is the mix of MongoDB operations that I want to have for this. But it also provides, especially if you're a Java developer, a little bit of insight on developing basic functionality in Java. The last tool that I'll mention, which is not a MongoDB specific tool, is called JQ. And this is open source command line tool processor, which allows for the parsing of JSON. And those who don't know, JSON is the basic way in which documents in MongoDB are represented in a human readable way. Having the ability to parse those as they come out of something in MongoDB is terribly useful, because everything in MongoDB is a JSON document at one time or another, both the user data, but also when we are interacting with MongoDB itself, especially at the command line level in, say, the Mongo shell. Almost everything that we get back that we are told or that we query from a Mongo server somewhere comes back as a JSON document. Truly everything in Mongo is a JSON document. And therefore, the ability to parse this out is extremely useful. Now, this means you need to, if you don't already know it, learn JSON. That is another beginner tip. Get familiar with JSON if you're not already. So at the end of the day, at the end of this presentation, assuming you've listened to the entire thing, what should we take away from this? Number one, come to MongoDB with an open mind. It behaves differently, it's built differently, it's predicated on different things. Then you're probably useful in most other DBMSs. Yes, if you're coming from Cosmos, if you're coming from DocumentDB, if you're coming from other document-based DBMSs, it won't seem as foreign. But come with an open mind, especially if you're coming from relational. Drop your preconceptions at the door. You can always pick them up later, but it will help you as a beginner to be less frustrated. Secondly, immerse yourself in the MongoDB community. I mentioned the community forums before. It is a great place to ask, to learn, even eventually for you to mentor. There are a lot of freely available resources available to beginners. All the links that I gave you, some of the tools, that's a very, very small set. Those just happen to be some of my favorites that I mentioned there. All out there. You do not have to be a customer of MongoDB Inc. to be able to avail yourself of almost all this stuff. Avoid common initial mistakes. That can really help make a difference in your satisfaction, in your confidence, in how quickly you learn things, in not getting discouraged, or at least not getting discouraged so easily. Lastly, not to be a dead join, but joins are expensive, and as such, they should be avoided if at all possible. And that means proper schema design, proper data design. And usually that means denormalizing rather than normalizing. Now, this week, or online, if you're listening to this after the week in June of mongodb.live, there are other recorded related events of interest, which I will point out for you. The first one is a talk entitled The MongoDB Community, an Ecosystem of Success. Second one is moving from RDBMS to MongoDB, unlearn your biggest learnings. Sound familiar? There's also a session on MongoDB tools everywhere. If you were intrigued or by the few that I mentioned, want to learn more, definitely one to take out. And lastly, this week, we will have some live Ask the Experts sessions. These are things that have been incredibly successful in the past at MongoDB World. These are almost always staffed by the best technical experts at MongoDB, consulting engineers, solution architects, developers. And traditionally, it was a walk-up kiosk where you could get an appointment for 20 minutes with a MongoDB expert to talk about anything. We have those this year at .live. And I would strongly recommend signing up for those. I will be doing several of those. Most of my peers will as well. These are terribly useful if you're brand new at Mongo and you're at .live and you're being bombarded by any number of different messages and tools and products and functions and features, and it's really useful. So with that, we will wrap up, and I will first say, if you've got questions or comments, there's actually going to be an interactive live session on Tuesday the 9th at 3:30 p.m. Now, if you are listening to this and it's past that, if you've got very simple questions, you can actually reach out to me, and my email's at the end of this. Shout outs before we're done. Shakir, a senior TSE, MongoDB, actually put a version of this talk together for internal users, for tech support users a while ago. So a shout out to him. And Gilberto, one of my peers, helped to review and tighten up this presentation. So shout outs to both of those. And with that, I will say thank you very much. There is my email address. And there's the site I mentioned earlier. If you've got simple questions after .live, feel free to reach out to me. I would love to make you successful as well. Thank you very much.